streets, I'm a mobster. You got 50 whole bed, you'll be my sponsor. Them snakes on the plane, me and Kanye Conda. Yeah.
So let's walk through an example here. So let's say we're given something like y prime is equal to 3 times y plus 5. Okay, that looks easy enough, right? It looks pretty linear to me because we have this y prime, some first derivative of the function is equal to some function of t or whatever, and that could be a function of t, honestly. So our a of t could be equal to 3, and our f of t is equal to 5. No big deal. There are just no t's there, which is fine. I'm not complaining. So anyways, so when we have this, remember the first thing we do is subtract this over to the left side. Okay? So we're going to subtract that, and we get y prime minus 3y is equal to 5. All right? And now, this is the point where we're supposed to find our integrating factor, right? Our mu. So what we want is mu times whatever's on the left side, everything on the left side. This has to equal mu times y, and then everything to the prime, I guess you could say. All right? So when we do this, I always like to rederive, or that's the saying, is rederive the formula or the process every time I do it so that I understand what's going on. So mu times y prime minus 3 mu y, that's what's on the left, and then we have mu prime y plus mu y prime. So these ones will go away. You can cancel those out, and we can cancel out the y's here. So we just get mu prime is equal to negative 3 mu, okay? So we get d mu dt is equal to negative 3 mu, and then we have our like a mini separable equation here, so negative 3 dt, we integrate, so we get ln of mu is equal to negative 3t, and we just exponentiate both sides, so e to the whatever. So we just get that ultimately, I'll just write a little arrow here, ultimately our mu, our integrating factor, is going to be equal to e to the negative 3t. Okay? So now that we have that, okay, so now what do we do with that? We found our integrating factor, and remember the point of it was to multiply by it on both sides, specifically so that we can get the left side in a more easily integrable form. I believe that was grammatically correct. So anyways, so we're going to multiply by this on both sides, so we have e to the negative 3t times y prime minus 3y is equal to e to the negative 3t times 5. Okay, we can't forget the right side, because whatever you do to the left, you have to do the right, the whole like golden rule thing. So anyways, and so the thing is that this side can consolidate down into e to the negative 3t times y, and then just you stick a prime there. Okay, that's where we came from, right? So this is what we were trying to do. That's where we're getting to. All right, and then on the right side we have this 5 times e to the negative 3t. So now we're at this point, and let's continue this on the next slide, okay? So we have e to the negative 3t times y, and then everything prime, and then is equal to 5 times e to the negative 3t. And on both sides now we're just going to integrate with respect to t, and on the left side this is nice and easy. Those just cancel out, so we get e to the negative 3t times y is equal to, and then we do have to integrate on the right side, which isn't a big deal, right? So our u is like negative 3t, so that means our du is like negative 3 dt. We get dt by itself, and that is du over negative 3 here. Okay, so we just replace, we're just doing u substitution here. Okay, so that 5 just stays out in front, we can say. And this is e to the u, because we're replacing the negative 3t with a u. And then dt is replaced directly by du over negative 3. Okay? So now we just get, this is negative 5 over 3 times the integral of e to the u du. And the left side can just stay the same. It'll just hang out there until we've dealt with the right side. So this is equal to negative 5 over 3 e to the u, and u is a negative 3t. So that's all we have there. And we can't forget our plus c, because we have an indefinite integral here. And the last step now is just to get y by itself. So we simply just multiply by this, by e to the 3t on both sides. So if we have e to the 3t, then on the left side here, we see those cancel, and we just get y of t is equal to, and these ones, when we distribute those cancel, so we just get negative 5 over 3 plus c times e to the positive 3t. And let me make that look like a 3 instead of an 8. Okay, I think that's the best 3 I've like ever drawn. Okay, so there it is. That's our answer, our general solution to the original ODE that we were given. Alrighty, so if that wasn't enough, that whole first process, that was called, by the way, that's called the method of integrating factor, or something like that. Basically, you just use the integrating factor mu, right? So this mu of t that we found, that was called our integrating factor, or integration. I'll just write integration factor. That looks cooler. Alrighty, so that was our integration factor, and etc., etc. That's how we used it, blah, blah, blah. So now, I'm just going to introduce an alternate method that you could use. Some people find it easier, some people don't. I mean, I personally like the integrating factor method more, because that comes up in later problems as well, like more advanced problems. So anyways, so here is the alternate method. I'll explain it nonetheless. Alternate method. Okay, and this one is called variation of parameters. Variation of parameters. Sounds kind of cool, right? So let's see. Alrighty. So I think the best way to explain this is via an example. So what we're going to do is, let's say we're given something like this. So y prime is equal to negative 2y and then plus 3 or something. Okay? So the whole strategy behind this is to solve the associated homogeneous equation first. Okay? So let me write that. So what we're going to do is solve the associated that says associated homogeneous equation first. Okay? Equation first. And then we'll go from there. So I'll just make a little bubble around it. Okay, so what does that even mean? So the associated homogeneous equation, if you remember, homogeneous is when our f of t is equal to 0. So we're just going to pretend this guy doesn't exist temporarily, okay? We're just going to look, like kind of hone in on this equation here, all right? We're just going to solve that right away. Okay, so let's do that first. So this is like saying the same thing as dy over dt is equal to negative 2y, right? And then when we separate our variables here, we get 1 over y dy is equal to negative 2 dt. And when we integrate, respectively, we get ln of y, of absolute value of y, is equal to negative 2t, and then plus a c here. Okay, and again, it's important to note that even though we have this plus c, we're just going to automatically set it equal to 0, like we did with the integrating factor, just to make our lives easier, okay? At this point, we don't need that constant c to be anything in particular, so we'll just make it a 0, okay? So just ignore that for now, and we're going to exponentiate both sides to get our y of t is equal to e to the negative 2t. Okay, so this y of t, I always like to write a little h beneath it, because that means this is the solution to the homogeneous equation, right? This thing that I boxed, this is the homogeneous equation, okay? Because we're kind of disregarding that plus 3. So now, what our job is after we've solved this and found the solution to the homogeneous, what we do now is say, okay, so the solution to our overall linear equation that we began with, so now we're including the 3, okay? This solution to the overall one is equal to some function of t that we don't know yet, times the solution to the homogeneous equation, which we just found, okay? So this is the important part. This is like kind of like the leap that we make. It's just important to understand what's going on here. So in order for this to be true, then that means that in our case, for our problem, we have some random unknown, so I'll just write unknown function of t, okay, times the solution to the homogeneous, which, like I said, in our case is this. So we're going to plug in an e to the negative 2t here, okay? So let's take this, and again, I'll bubble this one, so it makes it a little bit different from the boxed things, okay? I'm going to take this thing and continue with it on the next slide, okay? And I'll show you what we're going to do with it. So we have y of t, which is our solution to the overall ODE that we began with, is equal to some unknown function of t times e to the negative 2t, which we found to be the solution to the homogeneous equation, right? And then just as a reminder, here's our ODE. this is y prime is equal to a negative 2y plus 3. Okay, so maybe you can see where this is going. We're just going to plug in y and any of its derivatives that we need into this original ODE and solve for our v of t. Okay, and once we solve for our v of t, we're just going to plug it back into here, and then that gives us our general solution. Okay, so we already have our y. This is this whole thing here. And then our y prime, let's figure that out. So y prime is equal to, that would be, we're just going to use the product rule. So v prime of t times e to the negative 2t. And then we have plus v of t times, and now we derive the second term. So that would be negative 2 e to the negative 2t. Okay? So now that we have that, we can just plug that into the left side here, because for our y prime, right? So now we're left with something that looks like v prime of t times e to the negative 2t. And then minus a 2 v of t e to the negative 2t. So that's on the left side. This is our y prime is equal to, and then according to our ODE formula, we have negative 2 times y, and now y, we're just going to plug in everything we see here. So v of t times e to the negative 2t, and then plus a random 3 there. Well, not a random 3, but that's because of the equation told us to put a 3 there. Okay, so we actually see that these two things, this term here and this term here, are exactly the same. So those will cancel out nicely, right? And then we can get v prime of t times e to the negative 2t is then equal to 3. So that's a pretty simple equation, right? And now we're just going to simplify. We can multiply. We can we'll multiply by e to the positive 2t on both sides, e to the positive 2t. So these ones cancel out, and we get v prime of t is equal to 3e to the 2t. We're going to integrate with respect to t on both sides so that we can obtain that v of t, our unknown function, right? So this turns into v of t is then equal to 3 over 2 e to the 2t, and then plus a c, plus our constant c. This is where we're going to keep our constant, okay? Because we're nearing the end, alrighty? So now we have solved for our unknown function, and so now it is known. Anyways, so now that we have our v of t, we're just going to plug it right back into this thing here, okay? And so our general solution is going to be y of t is equal to v of t is now this guy. So we're going to plug in 3 over 2 e to the 2t plus c. That's our v of t, okay? We just leave it as such. And then we have e to the negative 2t because that came from our, remember that was the solution to our homogeneous equation. All right? So finally, we're just going to simplify. We'll distribute this to both of those terms, and we get y of t is equal to a 3 over 2, because those cancel out, right? And then we have plus c times e to the negative 2t here, and that is our general solution to the inhomogeneous equation. All right, that was using variation of parameters. Okay.
Yeah. Overseas nigga. Top flow, clear windows, nigga. Glass house.